Bonjour. Today we start on a new chapter on probability. This is chapter 5 in the book, and the book doesn't go into much detail about this concept and this topic. I will go into a little bit more detail than is there in the book, and this is one of the most fascinating branches of mathematics because remember in the first introductory audio or video that I sent you, on the very first day of the course, I said that maths helps you take better decisions in life, and there can be no better example of this than probability. Very often, if we don't know maths, we make major mistakes in calculating probabilities, and since probabilities are part of our everyday life, you can make mistakes that can affect your life very seriously. I will give you some examples uh, of this and as we go along. So let's start with the definition of probability. So probability is a branch of mathematics that concerns numerical descriptions of how likely an event is to occur, or how likely it is that a proposition is true. Basically, probability is a branch of mathematics which gives a numerical value to something that may or may not happen in the future. So, is it likely that Kimda will break the 100 meters world record? No, the probability of that is 0. Is it likely that I will teach maths tomorrow? The probability of that is very high. Is it likely that it will rain tomorrow? The weather prediction says 30% chance of rain. What does it mean? 30 is an accurate number, but I'm using also the word chance in that same sentence. What does it mean? So probability is a funny concept where you put a numerical description, that is, you assign a number to something that is going to happen in the future, and the numerical description describes how likely that thing is how likely that event is going to happen. So let us take, for example, let us take if you do a coin toss. When you do a coin toss, what do you get? You either get heads or tails. So what is the probability of getting heads the next time you toss a coin? The probability is half, because there is 50% chance that you'll get heads, there's 50% chance that you'll get tails. So there you're actually predicting the probability of getting heads or indeed tails, because the probability of both is the same, assuming the coin is nicely balanced, which most coins are balanced. Okay, so the probability of an event is a number between 0 and 1, or 0% and 100%. So if I go back and I say, what is the probability that Kimda will break the 100 meters world record? The probability is 0. What is the probability that Kimda will eat some food today? The probability is 1. It's a certainty. So this is a certainty. 0 represents an impossibility. Now, in this definition, they've used a word event, and so an event has a specific mathematical meaning, even though it is very close to the general meaning that we associate with the word, such as eat lunch today, or break the world record, or or rain tomorrow. These are all events. But in mathematical, in this particular video itself, I will tell you the mathematical definition of an event. Okay. So here, this is just what I said. Probability 0 means that the event is impossible. probability 1 means that the event is certain. So if you throw a die, I think it's called dé, une dé en français, or un dé, I'm not sure, then you will get 1 or 2 or 3 or 4 or 5 or 6, and we can calculate the probability of getting any one number. Okay, but if I say what is the probability of getting 8, if I throw a die, and the probability is 0 because there is no number 8 on a die and it will never come up as a throw. Okay, so I already mentioned the coin toss. We get heads or tails, and there is an equal probability, and these are the only possibilities. No, you either get heads or you get tails. You don't get a third thing. We'll ignore the the case where it ends up on edge. It stands on an edge, which is very rare and really doesn't happen. So in this case, we'll say P, representing probability. Heads is the event, is 0.5. So about half the time you should get heads and half the time you should get tails. Now I used one word just now and you might have noticed it. I said about half the time you'll get heads. Now this about is very important. All of these are probability. It doesn't mean it's a certainty. When it says that if the probability is 0.5 for heads and 0.5 for tails, it doesn't mean that the first time you throw, if you get heads, the next time you throw, you'll get tails. No. It just means that in every throw, the chances of getting heads are 0.5. The probability of getting heads are 0.5. Probability of getting tails is also 0.5. So if you toss a coin 10,000 times, you should expect heads 50% of the time, so total of 5,000 heads. The same for tails, so 5,000 tails. So if you toss a coin 10,000 times, you should expect heads 5,000 times and tails 5,000 times. If you do this experiment, you will not get these numbers 5,000 and 5,000. You will tend to get numbers that are close to that. You might get here 4,900 and 5,100. You might even get 4,800, 5,200. But over the long term, if you do a million tosses, they will the ratio between them will tend to be equal. That means you should get equal number of heads as you get tails. Now the first fallacy that most people have with respect to probability is, I can explain, is in an example. So knowing that if I toss a coin 10,000 times, I should get about half the time I should get heads and half the time I should get tails. So if I toss a coin 5 times and I get heads, 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 is T more likely in the 6th toss than H? If I toss it one more time, will I get T? Because it has to balance out. So is it more likely for me to get tail there than heads for a 6th time? Think about this. What do you think? If I am saying that when I toss a coin 10,000 times, I should get 5,000 heads, 5,000 tails. But if I've already tossed it 5 times and I've got all heads, assuming the coin is fair as in, it's balanced, then is T more likely in the 6th throw? Am I more likely to get tails in this 6th throw than heads? What do you think the answer to this is? Well, the answer is very simple. The answer is very, very simple. And the answer is an emphatic no. The 6th toss or the 1000th toss or the millionth toss has the same probability as the first toss. That is 50% chance of heads. So what it means is that the coin has no memory. What has gone in the past really has no bearing in random events. When you toss a coin, this is a random event. What has gone in the past has no relation to what might happen in the future. So you could get the first toss, you had a 50% chance of heads and 50% chance of tails. The sixth toss, irrespective of what has happened in the first 5 tosses, you still have a 50% chance of heads and a 50% chance of tails. If you do the 1000th toss, irrespective of what has happened in the 999 tosses before, the 1000th toss will also have the same ratio of probabilities. Or the millionth, irrespective of what has happened in the 999,999 previous tosses, you will still get, for the millionth toss, a 50% chance of heads and a 50% chance of tails. So I'll give you a practical example of this. So 6 years ago, I got my house repainted, and as I was supervising the painters, I heard them talking about numbers. And they were writing down on my wall with pencil some digits. And that didn't bother me because the wall was going to be painted anyway. It was lightly written with pencil. That's beside the point. But I asked them what these numbers are. So these painters, who were actually fairly educated and fairly well off, they rode really fancy motorcycles, they dressed well. One of them brought his wife to meet us once, and they were middle class people. So I asked him what I asked them what are these numbers. So they admitted, after a little bit of persuasion, they admitted that they participate in daily lotteries, and the lotteries are single digit lotteries. Every day one digit is pulled from 0 to 9, and you can bet on a digit coming up, and if you win, you get a small you win a little money. Of course, like all lotteries, the person who is guaranteed of winning is a person who is organizing the lottery, because he structures it in a way that if everybody is sort of spreading out and buying different lottery tickets for different numbers, different digits, different of the 10 digits that are possible, then he will always make a profit. So I said, oh, okay, how do you choose the number? Now, I know that, and now you know that every single lottery is independent of the one that have gone before. So they can choose any of the 10 digits and they'll have an equal chance of winning, which is 10%. Correct? 10%, because you have 10 different digits and you have only 10 digits. So you will have an equal chance of winning, even irrespective of the digit you choose, 0 to 9. No, they tried to convince me that digit 2 hasn't come up in 2 weeks or 3 weeks, so now it is guaranteed to come. So they were all going to bet on number 2 that evening. So I tried to persuade them, look, that is not how it works, and I couldn't. So they all bet on number 2, and as you can anticipate, they all lost their money on that particular day. So this is one of the very simple examples of how people get confused about probability and how it can make a difference in their everyday life, as in this case where my painters, all 3 of them, lost money. Now they might have lost money if they had bet on 4 or 6 or whatever, but they lost money because of their belief that digit 2 was bound to come up now, since it hasn't come up in a long time, and they bet quite a lot of money on that digit, and all of it they lost. So if we conduct this experiment, and by this experiment I mean tossing the coin 5 times, like we did here, 5 times, and we got 5 times heads, and the question I asked is, are we more likely to get tails in the 6th time? And the answer is no. If we conduct this experiment, tossing the coin 5 times, 1000 times, that means if I toss a coin 5 times and I call that 1, then I toss it another 5 times and I call it 2. So like that, if I do this experiment 1000 times, we can expect to get a sequence of 5 heads as many as 31 times. It can be shown that getting 5 heads in consecutively is not such a rare event. In 1000 times that I do this experiment, 31 times I will get, that is less than 1%, it's 0.3%, but it is not anywhere close to 0. It's not a very, very unexpected sequence. Later on we will look at this, in later videos we will figure out how we can calculate that. That is when we take sequence of coin tosses or any random experiment. Okay, by random experiment I mean any experiment involving random choices. Okay, so think about this one question that one statement I made earlier on. What do we mean by that there is 30% chance of rain? What do we mean by that? There is 30%. If you go to Google Weather or you go to any of these many weather prediction sites, they tell you that there is a 30% chance of rain tomorrow. So based on data that they have for today and for yesterday, and on what happened in similar weather 5 years ago and 4 years ago and 3 years ago, and what has happened in the past, they are predicting based on models that they have made, mathematical models, that tomorrow there is a 30% chance of rain. What does that actually mean? What does it mean, 30% chance of rain? Or the probability of rain, if you try to say it in a more mathematical way, that the probability of rain is 0.3, which is same as 30%. So I'll tell you the answer. What it means is that given the current conditions, given the accuracy of their models for predicting weather, what they say is that if we had, let's say they say that Pondicherry has a 0.3 probability of rain, that means 30% probability of rain. So what it means is if there are 100 Pondicherrys, in 30 of them they will expect that rain will fall. That's what it means. If when they say 90% chance of rain, it means that if there are 100 such identical situations of Pondicherry, then in 90 of them they will expect rain. So that's what it means when they say something, a probability of a weather event. Okay, so let's move on. So I will now, should we move on? It's 20 minutes already. So okay, I'll stop this video here, and I'll ask you one. Okay, I'll tell you in brief what we are going to do. We are now going to study two very technical terms, and these terms are, here you can see on page 68, very poorly explained here, but one term is issue. In English it's called outcomes, and the other term is evenma. In English it's event. So these two are very technical terms, in English outcome and event, in French issue événement, which I will define in the next video, which will be um, tomorrow. So now, before the in video problem is, I was going to give it later, I thought I would finish all this today, is that you have to take a coin and you have to toss it 30 times, and you have to count how many times you get heads and how many times you get tails, and you have to write it down, heads, tails, tails, tails. I mean, whatever sequence comes up, you keep on writing it down. You use the same coin. There is no right answer to this, there is no wrong answer to this. Don't make it up, just do it. It'll take you 5 minutes or even less. You can get somebody else to write if you don't want to keep on putting down the coin and picking up the pen, and otherwise you do it yourself. It'll take 5 minutes. So that is all the in video problem, and we will take up the two terms, issue and événement, in the next video. Okay, I stop here.